Digital inclusion is no longer optional. With new regulations like the EU Accessibility Act, accessible design is now a requirement across industries and regions. The A4Q Certified Professional Digital Accessibility Certification equips you with practical skills to design and build digital experiences that include everyone. From WC, AG guidelines and assistive tools to inclusive design, thinking, and accessibility testing, gain the knowledge to make a real impact. Learn, create, include. Get certified in digital accessibility.
Hello and welcome to everyone. Another session in the A4Q Summit 2026. I'm delighted to have with me for this session Lilia Gargouri. Hi, Lilia.
Hey, Debbie.
Hi. I'm not going to introduce you, Lilia, other than to say you and I have done interviews before, and I have to say you're a most inspiring woman and an absolute leader in the world of quality and testing, and I know that you're going to have some really great information to share with the audience. So I'm going to get off stage as soon as I possibly can and hand over to you. Just a little note to everyone, please take note of Lilia's presentation, sit back, enjoy, but also think about voting for the presentation at the end of the session by going to Lilia's profile on the A4Q website. I'll give you a reminder later also. Lilia, over to you. Looking forward to this one. Thank you.
Thank you so much, Debbie. Hello, everyone. Thank you for joining and welcome to the A4Q Testing Summit 2026. Software development is currently changing fundamentally. AI is generating code, agents are making decisions, and systems are evolving faster than we can even conceive. And suddenly, quality is no longer just about bugs or passing pipelines. Quality now means trust. It means reliability. It means transparency, and ultimately accountability for systems that partially think and act on their own. So let's talk quality. My name is Lilia. I am computer scientist, senior software developer, senior quality engineer with main focus on scalable test automation for enterprise software. I am head of quality assurance at MGM Technology Partners, member of the German testing board, and also member of ISTQB Glossary Working Group. In case you would like to connect with me on LinkedIn, feel free to follow the QR code. Now let's move to the agenda. After a short motivation, we will explore what lies beyond functional testing. Then I would like to highlight the difference between quality assurance and testing. Afterwards, I will show how we can scale our tests systematically, avoiding both over-testing and critical gaps. And last but not least, I would like to talk about the different languages we use in our teams and why having a common language is essential for effective communication within the team. This presentation is addressed to software developers at first place and also anyone involved in a software development project. So let's start. Let's talk quality. As software developer, quality is just not me. This is the responsibility of the so-called quality assurance team. For most of my time, I focus on coding features. And now with Cloud Code, I am coding features and even writing unit tests faster than ever. If a feature works for me once on my machine, I set the ticket to implement it and throw it over the wall to the so-called QA team for testing. Unfortunately, they often reopen the ticket, saying it doesn't work in the test environment. That surprised me a lot because it worked perfectly on my machine. I know we will not release my machine to the customer. Nevertheless, I cannot understand why it's not working for them. So a ping pong starts between me and them till they are satisfied with the quality of the feature, and then we set finally the ticket to done. Sometimes I get a bug ticket from them that I cannot reproduce on my machine. So in those cases, I reject the bug ticket immediately. Why? Because a bug that I cannot reproduce locally, it simply doesn't exist for me, and therefore is not my problem. Sorry, guys. In our weekly dev meeting, everyone gives the project manager the green light to deploy the feature to production by saying done. Everyone is meaning done for me. So from my perspective as software developer, the feature is implemented. My single happy path works brilliantly. I have few unit and integration tests passing. I am good. For the tester, done means no functional bugs found and the specified test cases passed. We all mean done from a mostly functional perspective. Then production happens, and unfortunately, the customer reported a performance issue, so a non-functional defect. As developer, I can protect myself easily by saying, hey, sorry, guys, that wasn't part of the ticket. I implemented exactly what was asked. So let me tell you two things. First of all, please keep in mind done for you is not the same as done for the product. Undefined quality is in fact a silent accepted risk. Secondly, when acting like this, with this sorry guys mentality, you are shifting the risk, shifting the responsibility to the team. This is not seniority and this is not leadership. Why? Because leadership is about taking responsibility for the team and for the product as a whole, especially now in the age of agentic coding and AI-based systems, where responsibility becomes even more critical and accountability moves to the center of everything we build. You can see here the 4 test quadrants as described in ISTQB foundation level syllabus, which I highly recommend to anyone involved in a software project. So most of the time during our conversations, we talk functional. We rarely talk about the non-functional aspects. And as you can see, they build the half of the picture, and they are critical for the product. So what is beyond the functional testing? ISO 25010 defines the quality characteristics of a software product. Beyond functional suitability, we have 8 further quality characteristics, and each of them contains more than one sub-characteristic. You see? So we talk most of the time functional. And sometimes we talk a little bit about performance or security, and we treat them optional. So maybe in the next release, maybe if we find time, we could conduct maybe a little bit of performance analysis. The truth is there is no maybe. These are quality characteristics of your software product. You cannot just ignore them. Let me give you an example. As a software developer, when starting implementing a feature, you should consider modularization, analyzability, reusability, testability, fault tolerance, scalability. You see, there are many aspects to consider from the beginning. You don't build quality at the end of the story. You see, let's give you another example. If you already have a software product and you think, now I need to make it accessible, digital accessibility. For legacy systems and existing product, this means a lot of reconstructions, refactorings, workaround, technical depth. So it's not easy. It's hell of work and a lot of cost. This is very costly, very expensive, very risky, time consuming. You don't want this, right? ISO 25059 extends the ISO 25010 with AI-specific quality aspects for AI-based systems. So we have here, for an AI-based system, the functional correctness is not absolute, is not an absolute correctness of 100%. Why? Because we are dealing with probabilistic systems. Secondly, we have the functional adaptability because AI systems learn and adapt from data. Under reliability, we have the robustness. So AI systems have to be reliable under uncertainty. And from the end user perspective, we have the user controllability, which means the ability to influence or override the AI behavior from the end user perspective. Also, as an end user, I want to understand the outcome of AI and the decisions taken by AI, which is transparency. And last but not least, we need the ability to prevent or mitigate harm through intervention, which is under the quality characteristic security. One of my key takeaways from the last Swiss testing day is the following statement attributed to Socrates, and I like this statement a lot, is saying, the beginning of wisdom is the definition of terms. So let me start with the definition of the term quality. According to the IRIB glossary, International Requirement Engineering Board glossary, quality in systems and software engineering is the degree to which a system satisfies the needs of its stakeholders. So before starting building a software product, we should ask and identify what are the quality characteristics expected by the stakeholders of this software product. Then we should define which ones are critical. We should prioritize them, then analyze what kind of risks do we have if the quality characteristics are not met. Then we can consciously accept the risk or mitigate the risk. So if we don't define quality, we don't engineer quality, we don't implement and test quality. So quality is not something you can expect it happening at the end of the software development lifecycle on its own, or you leave it to the so-called QA team. This is not true. Now let's move on to an important distinction between quality assurance and testing. These terms are often used interchangeably. We mix them up and we treat them as if they mean the same thing, but they don't. Given the beginning of wisdom is the definition of terms, let's have a closer look. Quality management consists on two main pillars, quality assurance and quality control. Testing is a main activity, a central practice of quality control. It is product-oriented. It evaluates and corrects the existing system. It's corrective. On the other side, quality assurance is process-oriented. It's a preventive approach. It includes the implementation and improvement of processes, applying to development and testing processes. This is the responsibility of everyone in a project. One of the key preventive QA activities that is becoming even more crucial, critical, especially now in the age of agentic coding, is requirement analysis. It prevents misunderstanding long before we implement or we generate code. In test cases, now with Cloud Code, you are generating code. So the requirement analysis is making sure that we want to build the right thing right. What happens here, the so-called three amigos principle, you bring three different representatives, one software developer or software development representative, one QA representative, one business representative. Why? Because you are spotlighting different perspectives. And then you do systematic review of the requirement systematically. This is not a one-shot activity. It has to be done every time systematically. So you review systematically the requirements at an early age. You identify the gaps, the ambiguities, the inconsistencies very early. Then you document, you evaluate, and you resolve the identified deviations, prior to implementation, long before you start coding. So you have clear acceptance criteria understood from all of us, and then you have a very reliable foundation for implementation and testing, regardless you are using AI for code generation or not. What happens here, you reduce a lot of ping-pongs, you prevent rework. It's time saving, you reduce the risk, and you ensure your product meets the stakeholders' expectation. It's really a very crucial activity to prevent defects before they even exist. As software developer, engineering is much more than coding. Otherwise, you should be called programmer rather than software engineer. Engineering includes many activities preventing defects to exist. Engineering is questioning and clarifying many critical aspects for the software product. This includes requirements, should be clear, technical specification questions, modularization, reusability, architecture, scalability, maybe migration, API, integration, code review, security, performance. You see a lot of aspects. Most managers think the number of bugs found is a QA KPI to evaluate if the QA team is doing a good job or not. I don't agree. It should be the other way around. Developers with a high defect rate are considered as a high risk for the project and the product. Now let's talk about scaling tests. So under quality control, there are different test techniques to consider when testing. If you don't know these techniques, you need to catch up and to learn them. Here I recommend the ISTQB foundation level. Why they are important? Because these methodologies, the methodologies of these techniques help you to systematically and efficiently test the right thing. Scaling the tests in the breadth means applying multiple test techniques to the same test condition to uncover different classes of defects. How far you go with each test technique depends on the risks. High risk require deeper coverage, so you scale in the depth. This is how to scale the tests. If you jump from the requirement to the test case, most people do, you test by chance, you test randomly the right thing. Breaking down the requirement into conditions is crucial. You can then apply the appropriate test techniques to each condition and derive systematically test cases and test data. By doing this, you prevent both over-testing and critical gaps. If you cannot write conditions for the requirement, you don't really understand the requirement. Deriving test data from the conditions make test data manageable, complete, consistent, and even traceable. So how do I know I have tested enough? This is a key question. How do I know I have tested enough? If you define your conditions, you apply the appropriate test techniques, you understand which quality characteristics and risk must be addressed, you know when you have tested enough. Now let's talk about the shared language, and let me start with a true story. In one of the projects where I work as QA consultant, the DevOps colleague shared a slide that included, among other things, the wording pipeline tests. So I asked him, what do you mean by pipeline tests? As it happens, I am part of the ISTQB glossary group, and I know that this term does not exist in the glossary. So he explained to me that he means any kind of test running in Jenkins. So depending on my role in the project, I can guess now what it means and mostly what it means to me. So grouping these tests under one single label simply because they are automated and run in the pipeline is misleading. is misleading, is dangerous. You are treating testing as one homogeneous activity, hiding the different objectives, risks, responsibilities of each test level. You remove the distinction between the test levels of a test pyramid as described in ISTQB foundation level syllabus. Each test level exists to address different types of risks. It provides feedback at different times. It answers different questions. Sorry. And at each level, you can address different quality characteristics across the different test levels. For example, at low level, when implementing the features at component level, you can address partially functional suitability, fault tolerance at code level, modularization, testability, and so on and so forth. By the way, and this is a side story, I was once speaking at developers, and during the break, the recruiting lady told me, when interviewing developers, they don't ask them coding related questions. They ask them about the test pyramid. The candidates that don't know about it, they are kicked out systematically. Why is this company doing this, the recruiting like this? Because quality matters to them. Because building a software product is much more than only coding. It's about quality. Quality is key. So let's talk about the shared language when having conversations, meetings, dailies within the team. We talk every day 4 different languages at the same time. By the way, this slide is produced by the German testing board. So the first language is the domain language. So if I work in automotive, I talk the automotive language. Then the second language is the technical one, because we deal with CI tools, Git, and other frameworks. So we talk the technical language. Then, and because we are building a software product, we have requirement engineering, software architecture, and quality. We talk the language of all of this. And we should here use the glossary, because we have three boards internationally providing a glossary with very valuable words. And it's important to use the glossary is open. Yeah, use the URL of the glossary, search for the wording rather than inventing the word and spreading wrong understanding and wrong wording. You know, wrong word, wrong impact. And if you use the glossary, you make sure that you use the right wording and you are improving yourself, you are improving your team and your company at the same time. Yeah. And if we talk about, for example, regression tests within the team, it's one word. We have one common word and we have the same understanding. The fourth language is the language of the project or the company. So for instance, if the project language is German and my German is not good enough, I am causing inefficiency in the communication within my team. Why? Because I miss the context. I might misuse words or don't find the word and communicate different. And this is important that you identify the gaps you have and then that you improve yourself, your language, your wording. And for any team lead or project manager, please identify the gap within your team and then send the people to the right trainings to improve this. If you improve the wording, you improve the shared language, then you are efficient when communicating in meetings. You save a lot of time. You prevent misunderstanding. Let me summarize. Effective communication starts with a shared language and a shared understanding. Please use the glossaries. Please do not invent pipeline tests. Quality engineering is an integral part of the software development lifecycle. You build quality. This is not something happening at the end. And if we don't define quality, we don't engineer quality. Quality is not a role. It's not a phase, and it's not a department. The so-called QA team is not. Quality is a mindset. Quality is a shared responsibility. Stop hoping for quality and start engineering quality. Thank you so much for your attention.
Thank you so much, Lilia. As ever, a lot of shared wisdom there and information, which I know that people will find ever so useful. Let's see if we have some questions. Do you have any recommendations on how to improve collaboration between developers and QA?
I like this question because I was 15 years developer and now 12 years as quality engineer, so I know both sides. Some developer, if they get a bug ticket, they feel offended. They have then bad feelings. And then you have a conflict between the developer and the QA, and wars. And you don't want this. This is inefficiency, and this is not a good communication. Senior developers usually have a lot of respect and appreciation to QA teams and to QA work. Juniors have to learn this. Sometimes they have to learn this the hard way. So learning collaboration in general starts by accepting the person. It's about the human rather than the tickets. This is really important. So here at team building events, I recommend team building events after work or sport activities, for example, are helpful. So for instance, in my team, we play from time to another karaoke, for example, and we do some breakfast together. And as a leader, as a team leader or project manager, it's really important to keep an eye on the spirit and to spread a spirit of collaboration within the team. This is very crucial. I give you an example. In the daily, if we have a problem, a software problem somewhere, and I hear that one of my colleagues is using the wording, "It's my bad, this and this happened," I stop the person immediately. I don't care basically about the problem and what happens. I care about the wording. I say, don't use this wording. It's not about this. We learn each problem happens can only challenge us to improve our approach, our strategy, and improve us as a team. So it's a continuous learning rather than it's your fault, it's my fault, and blaming each other. This is the wrong culture when working. And working should be fun. It's a quality of life to have innovation and synergies within the team. So it's not a war between developers and quality assurance. They all sit in the same boat.
I guess if we look back at Socrates' quote and defining terms, part of that is defining the culture and how that culture needs to look. I think very, very important. We're moving to the end of time now, so we're going to have to end the session, but a huge thank you to you as always. And thank you to everyone for tuning in. We're just about at the end of the second day of the A4Q Summit, which has been absolutely wonderful. And I'd urge people to stay for the final sessions. Don't forget to vote for Lilia on the A4Q Summit website. You'll find her profile there. And one final huge thank you, Lilia, for a great presentation. Thank you.
Always welcome. Thank you so much. See you then.
Take care.
Digital inclusion is no longer optional. With new regulations like the EU Accessibility Act, accessible design is now a requirement across industries and regions. The A4Q Certified Professional Digital Accessibility Certification equips you with practical skills to design and build digital experiences that include everyone. From WC, AG guidelines, and assistive tools to inclusive design, thinking, and accessibility testing, gain the knowledge to make a real impact. Learn, create, include, get certified in digital accessibility,